Okay, continuing part 2 of chapter 6, section 1, algebra 2. We just finished B and we determined that answer was positive negative 2. And then now for C, we've got what is the fourth root of negative 1. And when we look at this, we have to realize this is an even index and a negative radicand, so there's no real root solution. And look at D. Now we have to do some math first. This one's a little tricky because we'd want to cancel this out and say, oh, that's negative 2. But you can't. You have to do the math first. So remember, PEMDAS, exponents, parentheses, exponents. So negative 2 squared is a positive 4. So we get radical 4. Now, what's the answer of radical 4? 2. Okay. We're looking for the positive. And that's how you do these sets of problems. There's a got it's here. You can pause and work these if time permits. Moving along, we need to know there's a property for the nth roots of nth powers. And as I just pointed out a minute ago on D, where is it? Right here. You want to be tempted to cancel out the square root and the power and say this is equal to negative 2, but that's not true. Okay, so we just proved, you've got to be careful with those. So when we do these things, we need to realize there's some properties that come out of our nth roots of nth powers. So for any real number a, to take the nth root of a to the nth power, if a is going to be equal to a if n is odd, but then if n is even, it's going to be the absolute value of a. Okay? So let's look at these into motion. Problem 3. When the radicand contains a variable expression, you must include the absolute value when n is even and omit it when n is odd. So we have to look at the simplifying radical expressions. What is the simpler form of each radical expression? And here we've got, what is the square root of 16x to the 8th power? So what we need to do is realize, okay, this is even index, so it's going to be absolute value. Our answer will be an absolute value. So what we have to do to solve these is, because this is a square root, we have to get the things inside here because we're trying to clear this radical sign. So we have to get it down to squares because that's what we're dealing with. So we've got 16. What can we square and get 16? 4 squared. And what can we square and get x to the 8th? We'll just divide it by 2. That's the trick, right? 8 divided by 2 is 4. So it's going to be 8, x to the 4th squared. So now we have the square root of 4 squared times x to the 4th squared. Now we can rewrite this as 4x to the 4th squared. Right here. Okay. And now we can clear the radical sign and the power. And don't forget, because it was even, you've got 4x to the 4th. Absolute value of, so it's 4x to the 4th. Okay, next. We have B. We have the cubic root of a to the 6th, b to the 9th. So the first thing we're going to do is try to clear these. So what can we multiply by 3 and get the 6? Well, it's going to be 2. So it's going to be the cubic root of a squared cubed, and b to the third cubed. And now we can rewrite that as the cubic root of a squared b cubed cubed. And now we can clear our signs, and we get, and this was odd, so we just leave off the absolute value, and it becomes a squared b cubed. Okay. So when it's even, you add the absolute value. When it's odd, no absolute value. Just the answer. So look at C. Now we've got, what's the fourth root of x to the 8th, y to the 12th? So we've got to rewrite it first. So what can we get it to the 4th power, right? And what's it going to be? X squared. And then y cubed to the 4th power, right? Because power 2 power multiply, that becomes x to the 8th, y to the 12th. And now rewrite it. X squared y cubed to the 4th power. Now we can clear them. And let's see, it's even, so it's going to be an absolute value, x squared y cubed, which is just x squared y cubed. Oh, excuse me. The y cubed stays absolute value because he's odd. Just the evens. So the index is even, so the absolute value symbols ensure the root's positive, even when y cubed is negative. Absolute value symbols are not needed for x squared, since x squared is always non-negative. Okay, so it becomes x squared absolute value of y cubed. Okay, so the absolute value stays on because he is an odd power. Okay, here's the got it's for these. You can pause and do these if time allows. And problem 4, last problem we're going to go through, says some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is A equals 10 times radical R, where A is the adjusted score and R is the raw score. If the raw scores on one test range from 36 to 90, 36 being the lowest, 90 being the highest, what is the range of the adjusted scores? So you have to decide what to plug in where. So we know our formula is A equals 10R. A is our adjusted score, so that's what we're trying to find. We want to find this. So that means R, our raw score, is the 36 and the 90. So we have to do this formula twice, one for 36 and one for 90. So there's the 36. A equals 10 times radical 36, which radical 36 is 6. 10 times 6 is 60. So the bottom of her test was 60. That's the adjusted score. So the child who made a 36 now has a D. And then the high score was 90. So 10 times absolute value of 90. I'm sorry, radical 90 is about 10 times 9.487, which comes out to about a 94.87, around a 95 when you round it. So the 36 to 90 being the raw scores, the adjusted scores now for her class is a 60 to a 95. So everybody's score, especially on the low end, went up really a lot. So the adjusted scores range from 60 to 95.